Hello students. Today we are going to discuss about composition and resolution of forces. Composition of forces. So what do you mean by the composition of forces? The process of finding out the resultant force of a number of given forces is called composition of forces. And resolution of forces, the process of splitting up the given force into a number of components without changing its effect on the body is called resolution of forces. So what do you mean by the force? What is force? Force. A force is a push or a pull on an object. Force is defined as an agent which produces or tends to produce, destroy or tends to destroy motion. Some kind of forces are there. Some of the list, as you can see, the applied force, gravitational force, frictional force, magnetic force, air resistance force, etc. There are many number of forces are there. And we have to discuss about the effect of these forces. It may be, or it may change the motion of a body. That is, if a body is at rest, the force may set it in motion. And if the body is already in motion, the force may accelerate it. Next, it may retard the motion of a body. For example, we are applying the force on the brake pedal, and then here we can here you can see that the effect of the force that your vehicle is going to stop or retard. And next one is, it may retard the forces already acting on a body, thus bringing it to a rest. And what are the characteristics of forces? A force uh, having this type of the characteristics. Some of the characteristics is shown in front of you. First one is magnitude of the force. That it means 2, 3, 4, 5, 6, 7, 8. These are the magnitudes. And line of action of the force. Line of action, what do you mean by the line of action? The force is applied, which point the force is applied, and which is the direction of the force. So we have to see the point and direction of the force. Next one is the nature of the force. Nature, that means either it is push or pull. The point at which the force acts on the body. So this is the most important, that that is the point on which the force is act. Principle of transmissibility of forces. Here you can see that this is the diagram. With the help of this diagram, we can understand this is the point of application of the force. That means one force is acting at point A, and here you can see the point B, or this is the line of action of the force. Here, if the that means this principle says that if a force acts at any point on a rigid body, it may also be considered to act at any other point on its line of action, will produce the same effect on the body. Here, the force is acting on the point A, and if the line of action of this force is same. Here you can see this is the line of action, and the force is acting at point A, and the effect is shown at point B. The same effect. Here you can see you can see that this is the same effect on the body. This force produces the same effect on the body. These are the system of forces. Coplanar forces, collinear forces, concurrent forces, non-concurrent forces, like parallel, unlike parallel. These are the main number of system of forces. Here you can see that the coplanar forces, the coplanar collinear forces. Coplanar, that means it is having a single plane. All the forces are acting in a plane. Or these are the collinear also. That means all the forces are acting in a line. Here you can see the coplanar concurrent forces. Coplanar, that means we have already discussed. That means concurrent forces. That means all the forces are acting at a point. All forces are meeting at a point. Here you can see that the parallel forces, coplanar parallel forces. So all the forces are parallel with each other. This is the example of parallel forces, coplanar parallel forces. This is a beam, or which is having three forces, W1, W2, and W3 are acting downward, and these are the two reactions are acting upward, and all the forces and reactions are in parallel. And the next one is non-coplanar and concurrent forces. These are forces are not acting on a single plane. Here you can see that X, Y, Z, and the concurrent forces, that means all the forces are meeting at a point. Here you can see the non-concurrent and non-parallel forces. These are resultant force. If a number of forces are acting simultaneously on a particle, then it is possible to find out a single force which could replace them. That is, which would produce the same effect as produced by all the given forces. This single force is called resultant force. Analytical method for finding out the resultant force of a given forces. First one is parallelogram law of forces. Second one is method of resolution of forces. We will discuss one by one. So first we will start from parallelogram law of forces. So this is the parallelogram law of forces. So first, what is the statement of law of parallelogram of forces? If two forces acting simultaneously on a particle, we represented in magnitude and direction by two adjacent sides of a parallelogram. Their resultant may be represented in magnitude and direction by diagonal of the parallelogram, which passes through their point of intersection. This is the diagram, or we can say this is the parallelogram. Here you can see that here are the two forces, F1 and F2. We represented in magnitude and direction. You can see here, this is the direction, and the magnitude is F1 and F2. And these are the two sides of parallelogram, OA and OB, and their resultant may be represented in magnitude and direction by diagonal. This is the diagonal, OC, diagonal of the parallelogram, which passes through the point of intersection. Here you can see that this is also diagonal, AB, but we cannot take this diagonal. We have to take the diagonal. Which diagonal? Diagonal of parallelogram, which passes through their point of intersection. Here, mathematically, you can see that the resultant R is equals to under root of F1 square plus F2 square plus 2F1 F2 cos theta, and this is the direction. You can calculate by this formula: tan alpha equals to F2 sin theta upon F1 plus F2 cos theta. These are the resultant and the direction we can drive by expression, drive an expression from this parallelogram. Next, the method of resolution. Method of resolution. What is the? This is the second. Yeah, we can say that this is the second one, or second method for finding out the resultant. The process of splitting of the given force into a number of components without changing its effect on the body is called resolution of forces. We have already discussed at the starting of this lecture. Here you can see these are the two forces, Fx and F by, or here this is the force F. So you can see this is the x direction and by direction. You can see here this is the force F is inclined with angle theta from x direction. So we have to split it, or we have to resolve it this in two directions, x and y directions. Here this force having the two components, F cos theta and F sin theta. So Fx is equals to F cos theta and F by is equals to F sin theta. And resolve all the forces vertically. Here you can see that this many number of forces are acting. In this particular case, three forces. I have taken the three forces. The three forces are acting at a point. Here you can see the F1 makes an angle theta 1 with x, and F2 makes angle with x, that is theta 2, and F3 makes an angle theta 3 with x. Or so algebraic sum of all horizontal component. So how we can calculate the algebraic sum of all horizontal component? So first of all, we have to resolve all the forces. So first one, we have to resolve F1, then resolve F2, then resolve F3. All the we have to we resolve all the forces in x direction and y direction, and after this we have to write algebraic sum of all horizontal components, that means all the x direction components, and all vertical components, that means in vertical direction. After this, find out the resultant of the given forces will be R is equals to under root of summation of h square plus summation of v square. Summation of h, that means algebraic sum of all the horizontal components, and summation of v is equals to algebraic sum of all the vertical components, and find out the resultant force R. After that, we have to calculate the direction also. Okay, how much amount or how much degree the resultant inclined from x-axis. So we have to calculate by this. Tan theta is equal to summation of v and summation of divided by summation of h. These are the direction. These are the sign conventions we have to take accordingly. Accordingly, the value of theta will vary depending upon the value of summation of v and summation of h, as discussed below. Here you can see the when summation of v is positive, the resultant makes an angle between the 0 to 180. But when summation of v is negative, the resultant makes an angle between 180 and 360. When summation of h is positive, the resultant makes an angle between 0 to 90 or 270 to 360. But when theta is summation of h is negative, the resultant makes an angle between 90 to 270. So we'll understand with the help of one example. This is the example. The following forces act at a point. These are the four forces, and find out the magnitude and direction of the resultant force. So with the help of this example, we'll start. Initially, we have drawn the directions east, west, north, south, and first one is 20 Newton inclined at 30 degree towards north of east. This is east towards north of east. This is 30. Next, 25 Newton towards north. This is the 25 Newton towards north. Next, 30 Newton towards north, not towards northwest. That is 45. Towards northwest. 35 Newton inclined at 40 degree towards south of west. Towards south of west. So this is the diagram we have made from this example or from this question. So first of all, we have to resolve all the forces to calculate the magnitude of the resultant force. After that, we have to calculate the direction of the resultant force. So initially, we will take one by one. So first I take this 20 Newton force. So first we have to resolve this 20 Newton force in east and north direction. So first, this is the first component, 20 cos 30, and this one is second component, 20 sin 30. This is second force towards, this is already in vertical direction, 25 Newton. So no need to resolve it in perpendicular direction or in horizontal direction. Or we can say, if you want to resolve these forces, so you have to resolve in this direction. So this how much amount of in each direction, or which component is shown in each is this direction. This is the 90 degree. You have already known this is the 90 degree, and the component is shown here, that is 25 cos 90. 25 cos 90, that means value of the cos 90 is 0. So that means this component is 0. Here next one is 30 degree, 30 Newton, 45 degree. Resolve this. This is 30 cos 40, 30 sin 40, and next one is similarly 35 cos 40 and 35 sin 40. So resolving all the forces horizontally. So this is the horizontal forces. Here you can see that this one, we have to calculate the summation of H. This one plus this one, that is 0 already, plus this one plus this one. We have to take along with the directions also. So this is the direction, east, this is west, this is west. So first I have east direction I have taken positive, and similarly these two directions are in opposite. So this 20 cos 30 minus 30 cos 40 minus 30 cos 45, or we have to after the calculation we get 30.7 Newton. Then the similarly in vertical direction 33.7, and as you know, the resultant force is equals to summation of H square plus summation of V square. So value of magnitude of the resultant force equals to 45.6 Newton. Now calculate the angle which the resultant force makes with the east. We know that summation of V upon summation of H equals to summation of V is equals to this, summation of H is equals to this. So we get this value, or theta equals to tan inverse this. So theta equals to 47.7 degree. Since summation of H is negative and summation of V is positive, therefore resultant lie between 90 degree and 120 degree. So thus the actual angle of the resultant equals to 180 minus 47.7 degree, that is equals to 132.3 degree. So this is the one of the example of resolution of forces, and you can solve these type of problems easily with the help of this example. Now the polygon law of forces. If a number of forces acting simultaneously on a particle be represented in magnitude and direction by the sides of a polygon taken in order, then the resultant of all these forces may be represented in magnitude and direction by the closing side of the polygon taken in opposite order. So this is the statement of the law of polygon of forces. So here you can see that the number of forces acting on a particle. Suppose this is the particle and these are the number of forces F1, F2, F3 and F4. We represented in magnitude and direction all the forces having a magnitude, that is F1, and this is the directions F1, F2 and F3, F4 as magnitude, and these are the directions. By sides of a polygon taken in order. So here we draw the polygon. So first initially we start from this point O. So OA, this is represented, that is F1 is represented by OA. Second one F2 is represented by AB. F3 is represented by BC. And F4 is represented by CD. And here you can see that then the resultant of all these forces may be represented in magnitude and direction by the closing side of the polygon. This is the closing side of the polygon taken in opposite order. Focus on this, taken in opposite order. So I have already mentioned this is in opposite order because this is the first cycle in, you can see all the forces are going in this direction and this force is going in opposite direction. This is opposite. So here this is this opposite force is represented resultant. So we can say that the resultant of all these forces may be represented in magnitude and direction by the closing side of the polygon in taken in opposite order. So this is my lecture regarding the resolution and composition of forces. So we will meet next time with the other topic. Thank you. Thank you very much.